Hello, my name is Paul Neal, and this presentation is about the Westland Lynx helicopter. The Westland Lynx was first flown in March of 1971. It was developed by a joint English and French. What were you waving your hand for?
I saved it in the wrong location.
Because I thought you were trying to get my attention, and I realized you weren't. And then I said English instead of England. You will do that again? Okay. Hello, my name is Paul Neal, and this presentation is about the Westland Lynx helicopter. The Westland Lynx first flew in March of 1971. It was developed as a joint venture between England and France, as a direct competitor to the American Huey, which was the most popular helicopter during the Vietnam War era. The Westland Lynx was unique because it was the first fully aerobatic helicopter, meaning that it could perform loops and rolls. For this reason, it was chosen by flight demonstration teams such as the Blue Eagles and the Black Cats to perform at air shows. It also was fast. The Westland Lynx set speed records in 1972 at around 200 miles an hour and a modified version in 1986 at around 250 miles an hour. The Westland Lynx is capable of filling various roles, including utility and transport, attack, anti-tank, anti-ship, and anti-submarine, as well as armed escort. It served in the Falklands War as well as Iraq. There are several variants of the Westland Lynx. The originals include the Sea Lynx for the Navy, which featured wheels for maneuvering on carrier decks, and the Army Lynx, which featured skis and skids for landing on all sorts of terrain and potentially mud. The Battle Lynx was an upgraded version of the Army Lynx, which featured all-terrain tires. And the Super Lynx was an upgraded version of the Sea Lynx, which featured upgraded engines and avionics. The Westland Lynx is capable of transporting 2 pilots and up to 9 passengers. The armaments change based on the role, but can include a cannon, minigun, rockets, and various missiles. The mechanics of the Westland Lynx are composed of 4 composite blades, each with a honeycomb structure. The rotor is a semi-rigid design. The tail rotor, on the other hand, is fully articulated but still has 4 composite blades. The power plant is in the original 2 Rolls-Royce GEM 42-1 turboshaft engines. In the Super Lynx, these were upgraded to 2 LH Tech CTS 800-4N turboshaft engines. The specifications of the Westland Lynx include its mass, which is at all up, including fuel, payload, the whole helicopter is around 5,000 kilograms. This translates to a hover thrust requirement of around 52 kilonewtons. The rotor diameter is around 13 meters. This calculates to a disk area of around 130 meters squared. The tail rotor diameter is around 2.3 meters, and the disk loading was calculated to be approximately 400 newtons per meter squared. The induced velocity at hover is 13 meters a second. The Westland Lynx, after being proven in combat and speed runs, was upgraded with the BERP rotor. This was developed as a part of the British Experimental Rotor Program, and the blade served to improve efficiency, maneuverability, maximum lift, and top speed. It works by using some aerodynamic magic. The combination of a high angle of attack blade, thin airfoils, and a shifted area to adjust pitching moments allows the tip to perform well at high Mach numbers without stall. Essentially, the helicopter blades rotate slower while the helicopter is able to achieve higher cruise speeds. The performance of the Westland Lynx is dictated by the engine-provided power, which is 1,328 kilowatts for the regular and 1,890 kilowatts for the Super Lynx. The ideal power at hover was calculated to be around 660 kilowatts. The drastic difference shows that there is a lot of extra power for maneuvering and high-speed flight. The cruise speed is approximately 137 knots, the range is 530 nautical miles, and the endurance is 5.4 hours. This video shows the aerobatic capability of the Westland Lynx as performed at an air show. Here you can see the Westland Lynx engaging on a steep climb angle. As it approaches the top of its path, it nearly reaches zero velocity as it turns around much like a skateboarder in a half-pipe. After gaining some velocity back by diving, the helicopter enters a steep bank where you can see the BERP rotor blades displayed quite well. The sources for my presentation are displayed on this slide. The image credits are in the notes section of each slide. Thank you for tuning in.